Hello, welcome to the Cloud Developer Certification Preparation Series. In this section, we'll discuss 12-factor applications. After you complete this unit, you should understand how to design, develop, deploy, and manage an IBM Bluemix Platform as a Service application by following the 12-factor app methodology. The 12 factors include codebase, dependencies, config, backing services, build, release, run, processes, port binding, concurrency, disposability, dev prod parity, logs, and admin processes. In the modern era, software is commonly delivered as a service, called web apps or software as a service. The 12-factor app is a methodology for building software as a service apps that use declarative formats for setup automation to minimize time and cost for new developers joining the project, have a clean contract with the underlying operating system offering maximum portability between execution environments, are suitable for the deployment of modern cloud platforms, obviating the need for servers and systems administration, minimize divergence between development and production, enabling continuous deployment for maximum agility, and can scale up without significant changes to tooling, architecture, or development practices. The 12-factor methodology can be applied to apps written in any programming language and which use any combination of backing services, database, queue, memory, cache, etc. Here you see the list of the 12 factors and their definitions. We will get into each of these factors in the following slides. Factor 1. Codebase. One codebase tracked in revision control, many deploys. A 12-factor app is always tracked in a version control system. A copy of the revision tracking database is known as a code repository, often shortened to code repo or just repo. A codebase is any single repo or any set of repos who share a root commit. There is always a one-to-one correlation between the codebase and the app. If there are multiple codebases, it's not an app, it's a distributed system. Each component in a distributed system is an app, and each can individually comply with 12-factor. Multiple apps sharing the same code is a violation of 12-factor. The solution here is to factor shared code into libraries which can be included through the dependency manager. There is only one codebase per app, but there will be many deploys of the app. A deploy is a running instance of the app. This is typically a production site and one or more staging sites. Additionally, every developer has a copy of the app running on their local development environment, each of which also qualifies as a deploy. The codebase is the same across all deploys, although different versions may be active in each deploy. For example, a developer has some commits not yet deployed to the staging. Staging has some commits not yet deployed to the production. But they all share the same codebase, thus making them identifiable as different deploys of the same app. Bluemix utilizes IBM Bluemix DevOps services or Cloud Foundry deployment tools such as Urban Code Deploy, Gradle, and Jenkins to accomplish this method. Here's an example of the codebase methodology using Bluemix DevOps services. You create a project, select where your code will be, and select the options for your service. Factor 2. Dependencies. In this methodology, we explicitly declare and isolate dependencies. Most programming languages offer a packing system for distributing support libraries. Libraries installed through a packaging system can be installed system-wide, known as site packages, or scoped into the directory containing the app, known as vendoring or bundling. A 12-factor app never relies on implicit existence of system-wide packages. It declares all dependencies completely and exactly via a dependency declaration manifest. Furthermore, it uses a dependency isolation tool during execution to ensure that no implicit dependencies leak in from the surrounding system. The full and explicit dependency specification is applied uniformly to both production and development. One benefit of explicit dependency declaration is that it simplifies setup for developers new to the app. The new developer can check out the app's codebase onto the development machine, requiring only the language, runtime, and dependency manager installed as prerequisites. They will be able to set up everything needed to run the app's code with the deterministic build command. The Bluemix build pack adds external dependencies. Here is an example of a Node.js dependency. We've added cores in this instance. The third factor is config. In this methodology, we store config in the environment. An app's config is everything that is likely to vary between deploys, staging, production, developer environments, etc. Apps sometimes store config as constants in the code. This is a violation of 12-factor, which requires strict separation of config from code. Config varies substantially across deploys. Code does not. A litmus test for whether an app has all config correctly factored out of the code is whether the codebase could be made open source at any moment without compromising any credentials. In Bluemix, applications are parameterized via system-provided and custom environment variables. This is an example of the config factor being used within Bluemix using Hadoop. In the Factor 4 methodology backing services, we treat backing services as attached resources. A backing service is any service the app consumes over the network as part of its normal operation. Examples include data stores, messaging querying systems, SMTP services for outbound email, and caching systems. Backing services, like the database, are traditionally managed by the same systems administrators as the app's runtime deploy. In addition to these locally managed services, the app may also have services provided and managed by third parties. The code for a 12-factor app makes no distinction between local and third-party services. To the app, both are attached resources accessed via URL or other locator credentials stored in the config. A deploy of the 12-factor app should be able to swap out a local MySQL database with one managed by a third party without any changes to the app's code. Resources can be attached and detached to deploys at will. For example, if the app's database is misbehaving due to a hardware issue, the app's administrator might spin up a new database server restored from a recent backup. The current production database could be detached and the new database attached, all without any code changes. Bluemix uses the same mechanism for creating and binding to all services, including custom user provided. Here are different methods of how we can bind a service to an application. You can push the trader back application and bind it to the message broker and the data tier. In the fifth factor, build, release, and run, we strictly separate build and run stages. A codebase is transformed into a non-development deploy through 3 stages. The build stage is a transform which converts a code repo into an executable bundle known as build. Using a version of the code at a commit specified by the deployment process, the build stage fetches and vendors dependencies and compiles binaries and assets. The release stage takes the build produced by the build stage and combines it with the deploy's current config. The resulting release contains both the build and the config and is ready for immediate execution in the execution environment. The run stage, also known as runtime, runs the app in the execution environment by launching some set of apps processes against a selected release. The 12-factor app uses strict separation between the build, release, and run stages. For example, it is possible to make changes to the code at runtime since there is no way to propagate those changes back to the build stage. In Bluemix, we use CF build packs and immutable Warden containers to accomplish this. In the 6th factor, processes, we execute the apps as one or more stateless processes. The app is executed in the execution environment as one or more processes. In the simplest case, the code is a standalone script. The execution environment is a developer's local laptop with an installed language runtime, and the process is launched via the command line. Some web systems rely on sticky sessions, that is, caching user session data in memory of the app's processes and executing the feature requests from the same visitor to be routed to the same process. Sticky sessions are a violation of 12-factor and should never be used or relied upon. 12-factor processes are stateless and share nothing. Any data that needs to persist must be stored in a stateful backing service, typically a database. In Bluemix, application instances are stateless. Here you can see the Cloud Foundry Warden containers, which provide no clustered memory or shared file system. In Factor 7 port binding, web apps are sometimes executed inside a web server container. For example, PHP apps might run as a module inside Apache HTTPD, or Java apps might run inside Tomcat. The 12-factor app is completely self-contained and does not rely on runtime injection of a web server into the execution environment to create a web-facing service. The web app exports HTTP as a service by binding to a port and listening to requests coming into that port. In Bluemix, containers expose the HTTP port externalized via route. Factor 8, concurrency. With concurrency, we scale out via the process model. Any computer program once run is represented by one or more processes. Web apps have taken a variety of process execution forms. For example, PHP processes run as child processes of Apache, started on demand as needed by request volume. Java processes take the opposite approach, with the JVM providing one massive Uber process that reserves a large block of system resources on startup, with concurrency managed internally via threads. In both cases, the running processes are only minimally visible to the developers of the app. In the 12-factor app, processes are a first-class citizen. Using this model, the developer can architect their app to handle diverse workloads by assigning each type of work to a process type. In Bluemix, this is accomplished using the CF-scale and auto-scaling service. The process model truly shines when it comes time to scale out. The share-nothing horizontally partitionable nature of 12-factor app processes means that adding more concurrency is a simple and reliable operation. The array of process types and number of processes of each type is known as the process formation. In Factor 9, disposability, we maximize robustness with fast startup and graceful shutdown. The 12-factor app's processes are disposable, meaning they can be started or stopped at a moment's notice. This facilitates fast, elastic scaling, rapid deployment of code or config changes, and robustness of production deploys. Processes should strive to minimize startup time. Ideally, a process takes a few seconds from the time the launch command is executed until the process is up and ready to receive requests for jobs. Short startup time provides more agility for the release process and scaling up, and it aids robustness because the process manager can more easily move processes to new physical machines when warranted. Factor 10, dev prod parity, we keep development, staging, and production as similar as possible. Historically, there have been substantial gaps between development and production. These gaps manifest in three areas: the time gap. A developer may work on code that takes days, weeks, or even months to go into production. A personnel gap. Developers write code, ops engineers deploy it. The tools gap, where developers may be using a stack like SQLite, while the production deploy uses Apache. The 12-factor app is designed for continuous deployment by keeping the gap between development and production small. Looking at the three gaps, we make the time gap small. A developer may write code and have it deployed hours or even just minutes later. Make the personnel gap small. Developers who wrote the code are closely involved in deploying it and watching its behavior in production. Make the tools gap small. Keep development and production as similar as possible. Backing services such as the app's database, queuing system, or cache is one area where dev prod parity is important. Many languages offer libraries which simply access the backing service, including adapters to differentiate types of services. Backing services such as the app's database, queuing system, or cache is one area where dev prod parity is important. Many languages offer libraries which simplify access to the backing service, including adapters to different types of services. In Factory 11, with logs, we treat logs as event streams. Logs provide visibility into the behavior of a running app. In server-based environments, they are commonly written to a file on a disk, or a log file, but this is only an output format. Logs are the stream of aggregated time-ordered events collected from the output streams of all running processes and backing services. Logs in their raw form are typically a text format with one event per line. Logs have no fixed beginning or end, but flow continuously as long as the app is operating. A 12-factor app never concerns itself with routing or storage of its output stream. It should not attempt to write or manage log files. In Bluemix, Logaggregator provides event streams for applications. They can be drained to third-party log management system. In staging production deploys, each process's stream will be captured by the execution environment, collated together with all other streams from the app, and routed to one or more final destinations for viewing and long-term archival. These archival destinations are not visible to or configurable by the app, and instead are completely managed by the execution environment. The event stream for an app can be routed to a file or watched via real-time tail in terminal. Most significantly, the stream can be sent to a log indexing and analysis system such as Splunk or a general-purpose data warehousing system. Finally, in Factor 12 admin processes, we run admin management tasks as one-off processes. The process formation is the array of processes that are used to do the app's regular business, such as handling web requests as it runs. Separately, developers will often wish to do one-off administrative or maintenance tasks for the app. One-off admin processes should be run in an identical environment as the regular long-running processes for the app. They run against a release using the same codebase and config as any process run against that release. With Bluemix, we use push single-shot applications bound to the same services.